Yes, welcome to our lesson 3 of Ionic Equilibria. We are still looking at pH of solutions and specifically pH of strong acids and bases. This time we want to look at solutions formed by mixing a strong acid and a strong base. What could be the pH? Now, one thing that we need to know that once we mix a strong acid and a stronger base, of course a reaction will occur, and that's a neutralization reaction. And when a neutralization reaction occurs, if the molar quantities of the acids and bases are not equal, then one of them will remain in the solution as unreacted. Now, whatever remains unreacted will contribute to the overall pH of the solution, because in these cases of strong acids and bases, the salt that is formed does not hydrolyze. So when the salt does not hydrolyze, that means the pH is likely to be exactly 7. However, once an acid or a base remains in the mixture as an excess, then it will finally determine the pH of the solution. So we are given questions where a mixture is formed, and this mixture here, the number of moles mixed cannot react completely for complete neutralization to occur. One of the acid may remain in what? In excess, or the base may remain in excess, and in that case the pH will be either greater than 7 or less than 7, depending on what remains as in excess. So in this case, we could look at an example. Someone said determine the pH of the solution, the pH of the solution formed. Determine the pH of solution formed by mixing 50 cubic centimeters of 0.2 molar hydrochloric acid. This is hydrochloric or sulfuric acid with 50 cubic centimeters of 0.39 molar potassium hydroxide. So two acids, one acid and one base mixed together. So what do we expect? We expect that once we mix them, they will start to react. And when they are doing so, they do so in a certain molar ratio. And so we would want to find out how much of the acid reacts, how much of the base reacts. So what shall we do? When you get such a question, never fail to start. Once you see volume and molarity, then we can always calculate the number of what? The number of moles. So we would say the initial moles of sulfuric acid added. How many moles were added? These are, we could say, 1000 cubic centimeters of the solution is containing 0.2 mole. What about 50 cubic centimeters of solution? Will contain, we get 0.2 times 50 over 1000, and this would give us 0.2 times 50, and we divide this by 1,000. 0.01 mole of sulfuric acid. Now, how many moles of initial moles of potassium hydroxide added? Before we look at the moles of potassium hydroxide added, we would as well, because we are not interested in the sulfuric acid, as far as pH is concerned, we are interested in the hydrogen ions. So we would find out the moles of hydrogen ions in sulfuric acid. Moles of hydrogen ions. We could look at the ionization of sulfuric acid. When sulfuric acid, we could put this up here. When sulfuric acid ionizes, it would give us 2 moles of hydrogen ions and the sulfate. This is complete ionization. And from this, the moles of hydrogen ions in solution would be twice the moles of sulfuric acid. And this is 0.01 times 2, because this is 1 to 2. So the moles of hydrogen ions from the ionization will be times 2. And this would give us 0.02 mole of hydrogen ions from sulfuric acid. Now we do the same for moles of potassium hydroxide added. We say 1,000 cubic centimeters of the solution. The solution contain how many? 0.39 mole of potassium hydroxide. Now what about the 50? 50 cubic centimeters of solution will contain 0.39 times 50 over 1,000. And this would give us, erase this, so 0.39 times the 50 divided by 1,000. This will give us 0.0195. Now from potassium hydroxide, when it ionizes, what are the OH ions? OH ions, or we can say moles of OH ions from potassium hydroxide. When potassium hydroxide dissociates completely, it would give us potassium ions and OH ions. And in that case, we can say if this is 0.0195, then by mole ratio the other one should be the same. So moles of OH ions, will equal to 0.0195. Now, what is the kind of reaction equation occurring? Equation for the reaction. For neutralization, the hydrogen ions from sulfuric acid are reacting with OH ions to give us water. Now, when you look at this equation, the mole ratio is 1 to 1. 1 mole of hydrogen ions should react with 1 mole of OH ions. But what we have in the solution, the OH ion concentration, this one, is different from the hydrogen ion concentration. The hydrogen ion concentration is 0.02, whereas this is 0.0195, meaning this one is less than the other one. So what will happen when the reactions are occurring and the moles are not equal, yet they should be equal for complete neutralization? What will happen is that the value or the moles that are fewer will get finished when these ones are still there in solution. And so if they get finished, then the reaction will stop. So that means the one which is less is actually the limiting factor. The limiting factor for this reaction. The reaction stops because these ones have been exhausted. They are no longer there. So, meaning part of the hydrogen ions remains unreacted. And so we are interested in how much it remains unreacted, because it will finally determine the pH of the solution. So we shall be saying that moles of the OH ions reacted, moles of the OH ions reacted are equal to moles of acid reacted, and that will be of the smaller value 0.0195, because it is the limiting factor. Once it gets finished, then sulfuric acid has nothing to react with, and so the reaction stops. And that now takes us to the moles of hydrogen ions that remain unreacted. Remain unreacted. It would be the original 0.02 that we have, subtract the one that reacted. And that would give us 0.02. That will give us 0.0005 mole. So the hydrogen ion concentration that remains in solution unreacted is 0.005 moles. And so the question is, what is the pH of the resultant solution? The pH of the resultant solution, according to what we are seeing, must be less than 7, because the solution has excess hydrogen ions. However, in the expression of pH, if we say pH, it is equal to negative log base 10 molar concentration of hydrogen ions. But these are moles in a certain volume of the mixture. So this is not molar concentration. What do we do to change this to molar concentration? We shall be now saying, what is the new volume? New volume is 50 of sulfuric acid plus 50 of potassium hydroxide to give us 100 cubic centimeters. So that means these hydrogen ions are in 100. So we do now find out what about in 1,000, so that we get the molar concentration of hydroxyl ions. And so we shall say 100 cubic centimeters of the resultant solution. Of the resultant solution contains 0.0005 mole of hydrogen ions. What about 1,000? A 1,000 cubic centimeters of the solution will contain 0.0005. We multiply this by 1,000, and then we divide this by 100. The value would be 0.005. Now this is mole per decimeter cubed, and is fit to substitute in the expression of pH. So pH would be negative log base 10 0.005, and the value would be, so you say negative log of 0.005. This value is 2.3. pH is 2.3. By the fact that this value is less than, 7, I'm very sure this is a perfect answer for the pH of the resultant solution, since it contained some unreacted hydrogen ions. We could have many more other examples on the same and simply look at what do we do to determine the concentration. There is another question that we can look at similar, and this you will be doing following the steps illustrated in this video. You'll be able to do this on your own and get the answer or the resultant pH, or the pH of the resultant solution. In this one here, we are having calculate the pH of the resultant solution. Number 2, calculate pH of the resultant. pH of the resultant solution formed by mixing. 25 cubic centimeters of 0.1 molar. 25 cubic centimeters of 0.1 molar hydrochloric acid and 50 cubic centimeters of 0.1 molar sodium hydroxide solution. Sodium hydroxide solution. This is a number that carries the same working as the one we've just done, but for purposes of highlights, here you will have 25 of 0.1, you calculate the moles of HCl. Then you also calculate the moles of sodium hydroxide. But after calculating the moles of HCl, calculate the moles of the hydrogen ions. After calculating moles of sodium hydroxide, also calculate the moles of the OH ions. When you compare, you see that the concentration of hydroxyl will be greater than the concentration of the hydrogen ions. And yet by mole ratio, it has to be 1:1 for neutralization. So in the end, you see the answer that we shall get, the pH must be greater than 7, since the hydroxyl ion concentration is greater. And so you will try out the answer following the procedure of the one we've just done, and then you will be able to get the answer. And that is it for pH of acids and bases which are strong. In the next episode, we are going to introduce the pH of weak acids and bases. Don't miss.